Hey everyone, today we're going to talk about what is assembly. So assembly is a programming language, and I think we can end it there. Well, no, we should get into a little bit more detail. Assembly is an easier way to write machine code. That's basically what it comes down to. So inside of the computer, it's just going to have a bunch of bytes, and they might be things like a program might honestly just look something like this. And as a human being, this is hard to read. I don't exactly know what this means. So we needed a way to be able to tell the computer what to do and for it to figure this part of it out for us. Now there are people that are more fluent in reading hexadecimal, and they could look at this and go, "Oh, what you wrote is a bunch of gibberish and you obviously don't know what you're doing." More than likely. The number 13 could also mean something. Now, what we need to do is we need to discuss verbs and we need to discuss nouns. Verbs and nouns. So in English, a verb is an action. A noun is a person, place, or thing. Now you might be thinking, I did not expect to get an English lesson. This is computers. You have already done mathematics, Babylonian math. Now you're doing English language, and just bear with me. So if you look at this, verbs and nouns is what got us to the moon. So this is important stuff. You look at the computer here, you can see that there was clearly a noun in here, and the noun was number 33. So this type of stuff's important. Now, what you might be thinking, well, I have no idea what you're talking about. And that's fair, because I haven't really explained myself yet. So let's look at the word March. The word March is a noun. It's a month. Cool. If it's a verb, it is, it means to march, sort of like things that marching bands do around on sports fields. Then we have the word store. Okay, well that's clearly a noun, and that's a place where you buy things. But it also could be a verb, and that means to put things away for safekeeping. So now if I were to just say March store, you would say I need to march to the store. If I say store march, you might gather out of that, I need to store stuff in the month of March. Computers are kind of the same way. When a computer first wakes up, it gets power and its little heartbeat starts beating. It says, give me a verb. And that verb might be B0 or B4 or AA or whatever the number is. And that's a command. It's a verb. It means do this. And then after that, we'll say it's B0. Then we might pass in the number 15. And that's a noun, more than likely. Unless B0 happens to mean no operation, NOP, no op, which means do nothing, which just burns up time. It is a valid operation. And then what you're doing is you're buying time. It's like a delay. Can you imagine playing a game that runs at the full speed that a computer can think with absolutely no delay in it? Actually, that was a problem back in the DOS days. That's why computers had turbo buttons to slow them down. People were playing Doom and they couldn't beat the computer because the computer's running at however many billions of clock cycles, and the human brain just is not equipped to destroy monsters at that speed. So the turbo button would slow down the processor. Now things are less tied to the processor specifically and tied to milliseconds and things like that, so that faster processors don't do tasks faster than others. However, behind the scenes, when you get down to the low level, that's what no op does, is it tells the processor just do nothing, and I will tell you what to do after you're done doing nothing. Well, that was a tangent I didn't expect to go on, but let's continue. So we look at this first line of code, and this means nothing to me. To someone that works with hex all the time, it might mean something to them with hexadecimal characters. However, if I were to see this in Intel assembly, I would say, oh, you're moving 13 into the register AX. A register is basically a global variable built inside of the processor itself. And we'll talk more about that down the road as we get into actually writing in assembly. This is more of a high-level overview. Now, I did say Intel assembly. Let's say you wanted to move this byte into AX using AT&T assembly. So there are two types, two primary types. I'm sure there's definitely probably more than that, but we'll say for our little universe, there's AT&T or there is Intel assembly. Move AX 13H is going to be Intel assembly. AT&T assembly, which I am less familiar with, you would say I want to move a byte. The byte is 13, and you might not be able to specify it that way. You might have to do it this way. I'm not positive. Like I said, I'm not as familiar with AT&T assembly, so you get to watch me squirm a little bit. But into register AX. Now, I am more familiar with this. There are other people that are more familiar with this. There are advantages and disadvantages, I have been told. For instance, let's say you want to move. Now, AX can hold, it's a word, so it can hold 2 bytes. So if I want to pass in to AX, for instance, and this is synonymous, 0x and H, at least in Intel, for sure are synonymous. AT&T, I don't know. I'm not as familiar with it. I would say I want to move AA55, so move the byte AA and move the byte 55. So it's a whole word into AX, whereas in AT&T assembly, we would need to put move word into register AX. This specifies this as a register. This specifies that it is a number, an immediate or whatever it's called off the top of my head. I don't recall, but it's a number, and it's not like an address that you have to go find something and reference it. So we can store it in, and the difference is this means this, or AA55, like we have here. AX equals that. We don't have to say it's a register. Intel assembly makes the assumption that yes, that is indeed a register, and we don't need to specify how big the number is that we're putting into the register. Whereas this is more this direction. 13 goes into AX. All right, so there clearly are differences here, and if those people that know AT&T assembly are looking at this and screaming at their monitors, I'm sorry. I did disclaim that I am not super familiar with AT&T assembly at all. I'm sorry. I learned Intel assembly, and that is what I have used. And if you're watching this channel, that is what you're going to learn too. Unless I run out of stuff to talk about. Maybe then I'll learn AT&T assembly, and then I'll teach it to you too. How wonderful the world is that we can teach things that we learn. All right, so anyway, Intel assembly obviously though makes some assumptions for you. You're passing in a byte, it'll automatically do a byte. You're passing in a word, it'll automatically do a word. Here you need to specify what you're doing. You need to specify that these indeed are registers. There's people that like this because they feel that they can spot issues much easier. They look at this and they look at this and they go, oh, that doesn't line up. I am not as familiar with AT&T assembly. I'm not even going to guarantee that this portion right here is written properly. Oops, that was exciting. I meant Shift-Alt, not Control-Alt. No, I didn't. What am I doing? Well, well, I thought I outsmarted the computer. In actuality, the computer has yet again outsmarted me. All right, enough about that tangent anyway. Let's recap what we've learned. We've learned that computers basically have verbs and nouns, and one number, just like one word, can be either a noun or a verb. And just like in English, the word I thought of badger, but that is a verb and a noun. Computer. There we go. Computer's always a noun. I don't think you can say I'm going to computer something. You'd say compute. So just like that, there can be nouns that are not verbs. There can be numbers that don't mean anything as a verb in the computer terms as well. So the language thing does carry over. And when the computer first wakes up, it says, I'm looking for a verb. And you give it a verb, and then which is a number, and then you give it the following numbers that it needs to do its job. There are two different types of assembly primarily. There's probably others. I can almost guarantee that there are others, but the main syntax you'll have is Intel or AT&T with x86 stuff. You'll be learning Intel from me. AT&T is out there. If you see something that looks completely different and you're like, well, this is assembly and this is assembly, how are they different? This is why. There's different syntaxes. It's like a different dialect. You come to America, we speak one way. You go over to England, they speak very different. It's still English, but they use different words, they use different emphasis, and it's the same thing here. So there's a dialect over time that you'll probably like more than others, and it might be Intel, it might not be. And that's really all I have for you. Assembly is an easy way to specify hexadecimal, and that's what it comes down to. One other thing I guess I could throw out there is that it represents one computer process. Like this means move 13 into AX. Now, if you're writing in like C and you have some sort of variable and you're saying it equals this, and then if that's the case, I want you to do some stuff, and else I want you to do this stuff. And if we include the brackets, this is one instruction, this is 2, 3, 4, 5, 6, 7, 8, 9. If you look at the computer code, the equivalent assembly, I can almost guarantee you it is a lot more than 9 instructions that are happening. This if statement is a compare and a branch. There's a branch back. There's setting 0 flags, and there's a lot of stuff going on. When you work with assembly, you're telling the computer one thing it understands. You're saying, do this one task, and then I'll give you another task. When you work with higher level languages such as C or Java or Python or whatever you're working with, you might type in just a couple words like this, and it will mean do a whole bunch of stuff automatically for me. Now, when you get into higher level languages, basically anything other than hex and assembly, this being hex, this being assembly, you no longer generally have access to the registers inside the CPU itself. All that's taken care of for you. You no longer have, it's sort of like in Python, you don't have access to the memory per se anymore. You can't manually free memory and allocate memory out on the RAM. In C++ and C, you can do that. You definitely are going to be doing that all the time in assembly. But that's one of the things. The more conveniences that the computer does for you, the less control over the really small things you have. People often say they like assembly because it's really fast. Well, that's okay, sure. If you write garbage code, is it really fast? Probably not. No, it might be very, very slow because it's only as good as the code that is written. And these days, compilers are really good at writing the underlying assembly code for you. They know all the optimization tricks. They're going to be very, very fast at what they're doing. Now, are there edge cases where you might be able to optimize something? Absolutely. If you know what you're doing, there might be some little thing in code you can do that will save you a couple clock cycles here and there, and that could make all the difference. And that's the thing too. when you get into like C and other languages, you're not thinking about, oh, how many times is the clock going to pulse on the CPU? You're not thinking about that at all. In assembly, are you thinking about that? You very well might be. You might be looking at the data sheet and going, oh, it will take 4 cycles to do this, whereas it'll take only 3 cycles to do that. I really was tempted to show you a case where programmers do that, but we're going to try to keep this high level. And the moral of the story is, this is a lot easier. This is going to be more challenging. This gives you less control. This gives you more control. And in all honesty, it is kind of fun to be able to dig into the little bits of a processor and say, hey, I want you to do this or I want you to do that, and know that you're talking to the computer processor directly. So this video already went on longer than I wanted it to, but I hope you found it enjoyable and hopefully a little bit entertaining. And I try to use different vocal variety so that I'm not just speaking like my history instructor in high school that was monotone. That was not his, it was not his fault. That's just the way he talked. It did provide a certain level of entertainment sometimes because he would try to emphasize things and we knew he was. And he was a great guy. I'm not making fun of him at all. However, I'm trying to keep you at least a little bit entertained. So if you like this type of video, please like it, subscribe it, let me know, and we'll make more videos about this. We plan on, or I should say I plan on, going forward now and making some more videos that deal with assembly. I also will deal with other languages too, but I look forward to seeing you then.